Now we come to defining the dimensions and the relevant units, the corresponding units that there are. So obviously, right in the beginning when we started this course, we did discuss some standard units that we shall be considering. And just to recapitulate briefly, that we have a metric system or SI system, and also what we call as the British system, whereby we use the pound and foot, and on the metric side we use centimeter and seconds and so on, or kilogram, Newton, etc. So for the SI system. So, but however, there are 6 or 7 basic things, basic dimensions that we need to define, and we need to keep their units in mind. Everything else can be defined by using these dimensions. So this is what we need to go through. So what is dimension? It's a measure of a physical quantity without any numerical value. Measure of a physical quantity. So that is dimension. For example, if I say that a ship is 100 meters long, then the length of that ship is a dimension. We don't attach the numerical value to it, the length part. Similarly, in a cube, there is length into breadth into the height. That makes it a cube, the volume of a cube. But from our point of view, as far as dimension is concerned, length is a dimension, breadth is also a length, and height is also a length. So for us, they are all the same, and the dimension for us, it's a multiplication of 3 lengths. So length in that case, for that example, is a dimension. So these are the things. And then there is a unit attached to it. And what is a unit? It's a number that somehow try to measure that dimension. There are 7 primary dimensions, also called fundamental or basic dimensions, with the help of which you can almost measure any other variable also. So, and these 7 basic dimensions are for mass, for length, for time, temperature, electric current, amount of light, and amount of matter. So with the help of these 7 basic things, the other variables can be measured by making use of these basic things. All non-primary dimensions can be formed with their help. You can see here, for example, this is a distance between 2 points, which is 3.2 centimeter apart. This is a length. It has a dimension of a length. And we don't see 3.2 is the distance between 2 points. But if somebody asks me what is its dimension is only length. So this is the difference. Dimensions of a force, for example. In fluids, in motion, we talk about force every now and then. A short while ago, we were talking about momentum, which is a force. And the force has the unit mass into length over time square. So that will be equal to, if I try to write down in terms of its dimensions, then we write m for dimension of mass, L for dimension of length, and T for dimension of time. And since it is dividing here, so we show it as a division as something that is in the denominator. So dimension is a measure of a physical quantity without the numerical value that is attached to it, while the unit is a way to assign a number to that dimension. For example, length is a dimension, but centimeter is a unit. A meter is a unit. Second is a unit, and so on. The primary dimensions and their associated primary SI and English units are as under. So I believe that all of you are familiar with these things right from the school days, but anyway, for the sake of completeness, we have written them down, jotted them down here also, and we remind ourselves that these are the terms or the units that we will be using from time to time. And if we are working problems in terms of SI units, we use kilogram, meter, second, etc. And if we are using English units, then we are using pound, pound mass, pound foot, foot second, and etc. etc. So mass is denoted by M, length is normally denoted by L, time is T, temperature by capital T, and then you can see that in SI units we use it as Kelvin, and in English units it's used as Rankine. Electric current, we are very familiar that it is ampere, and similarly the other terms that are there. So the 7 basic things are here.